Algebra 2 students, we're going to do a little review here for our Intercept Form quiz or test or quest or whatever you want to call it. We're going to go through all of the skills that you need for this assignment, and that includes factoring, that includes completing the square, that includes graphing and analyzing quadratics. So there's a lot going on here, so let's see if we can work through this now. First thing, if I give you a quadratic and I say I want you to convert it to intercept form, that means we need to factor. So when you factor, you think of the leading coefficient as 1, and you multiply 1 times negative 48, and that's negative 48. We need to find numbers that multiply to negative 48 and add to the middle. The middle is negative 2. So if you want to make a little factor table, it's not a bad idea. Think of all the numbers that multiply to 48. 1 times, whoa, those aren't 4s. 1 times 48. 2 times 24, does 3 go into 48? Yeah, 16 times 4 times 12. 5 doesn't go into 48. 6 times 8, and then 8 times 6. So that's a repeat. It's got to be one of these. Now it's negative 48, so where do I put the minus sign so that these two numbers add to negative 2? How about negative 8? Right there. So when you're factoring, you need to split the middle. The numbers that you need, multiply to negative 48 and add to negative 2 is 6 and negative 8. So x squared doesn't change, but now it's going to be plus 6x minus 8x minus 48. It's called split the middle because you take the middle and you split it into two numbers that meet those requirements. Now we're going to factor by grouping. So you find the GCF of the first half. The GCF there is x, and you're left with x plus 6. Bring down your minus sign. GCF of these two terms, 8 and 48, is 8. And then it's x plus 6. The reason it's plus 6 is you've really factored out a negative 8. So if I work backwards, negative 8x, I need a negative 8 times a positive 6 to be negative 48. So just be careful with your signs. If you factor correctly, you should see that that binomial is shared. So we're going to factor out an x plus 6. And if you factor x plus 6 out of this term, you're left with the x. So we have x, and then if you factor x plus 6 out of that, you have minus 8. So what's left is right here, x minus 8. That's your other factor. So x plus 6 and x minus 8, that is in intercept form, and we'll come back to that in a minute, and we'll talk about finding the zeros. Next up, we need to convert to vertex form. So for vertex form, we're going to need to complete the square. To do that, we want these two on one side, and we want to move this over there. So I'm going to add 48 to both sides, and now I have y plus 48, and I'm going to leave myself a little blank. I'm going to have x squared minus 2x, and I'm going to leave myself a little blank right there too, because I know I'm going to complete the square. So I like to draw this little sketch to help me out. It's always x plus or minus half of b. If b is negative 2, half of that's negative 1. Now I square that because this is x minus 1 as well. 1 times 1 is 1. I'm adding 1 to both sides. I'm going to add a 1 here and a 1 there. Combine like terms, y plus 49 equals. On the right side, you're factoring, but you don't really need to factor because it's the dimensions of this square. X minus 1 times x minus 1 is x minus 1 squared. Last thing you got to do is move the 49 back over. So x minus 1 squared minus 49, and that is now converted to vertex form. So I'll make sure I write on the line. There you go. There's a y already there. How about that? There you go. X minus 1 squared minus 49. Now that we've got this thing converted to two different forms, we can now analyze it completely, and we should be able to do everything that we need. So first thing, let's see if I can maybe take this guy, and I'm going to, let's see, can I cut that? Cut. We'll come here, and we'll paste it, because I can't see it all, so it just bothers me. There's one. And I'll do the same thing with vertex form. And we'll take this guy and we will cut him too. And now we got both things just so I can see it all and talk about it all. And you know what? We also might want to get the other one too. So what was it? X squared minus 2x minus 48. That was the standard form. I don't feel like cut and paste it anymore. All right, so from standard form, you can easily see the y-intercept. The y-intercept is negative 48. Cool, that's standard form. That's way down here. We'll have to change the scale probably. From vertex form, you can easily see the vertex. If it's x minus 1, that means it's gone to the right 1, and outside minus 49 means down 49. So the way we write that is if it goes right 1, the x coordinate is positive, and if it goes down 49, now it's negative 49. The axis of symmetry is always a vertical line that passes through the vertex, so it's the x-coordinate of the vertex. And from intercept form, I know my zeros are, when does x plus 6 equal 0? If you want to write a little mini equation, x plus 6 equals 0 when x is negative 6, x minus 8 equals 0 when x is positive 8. You just subtract 6 and add 8. So negative 6 comma 0 and 8 comma 0, I like to write them as ordered pairs. If they're something I'm going to plot, I'll write them as ordered pairs. So let's change the scale here. Instead of count by ones, let's count by maybe about fives. So then this will be negative 25, and this will be negative 50. And this will be positive 25, and this will be positive 50. So let's plot our vertex. Well, first axis of symmetry is a vertical line right here, and I'll make that dashed because I like to see it as a dashed line. It's not part of the function. Then I'll plot my vertex at 1, negative 49, which is right here about. 0, negative 48 is right here. It's going to be tough to distinguish exactly, but that's pretty close. And then my x-intercepts are at negative 6 and at positive 8 right there. And I'll see if I can draw this thing. It's going to look something like that's, it's not best, but it's hard to do on this thing. There we go. That's pretty good. It doesn't really get vertical. I could probably stretch out a little bit, but that's it. That's our quadratic. We crushed it. We used all three forms and we completely analyzed it. Let's see what else we got to do. Solve by factoring. So if you're going to solve, you want to first set one side equal to 0 because we're trying to find zeros. So add 10 to both sides. Now it's positive 10. Now we need to find numbers that multiply to 1 times 10. So numbers that multiply to 10 and add to the middle is negative 11. 1 and 10 or 2 and 5. Since it's a positive, I think they have to both be negative. Hey, there we go. Negative 10 and negative 1. So x squared minus x minus 10x plus 10. Then you factor by grouping. GCF on the first two terms is x. GCF on the right two terms is 10. Then we got one more step, x minus 1 times x minus 10. And we're looking for zeros, so I want to know when this equals 0. The first factor equals 0 when x is 1, and this factor equals 0 when x is 10. So x equals 1 or x equals 10. That's cool, first one. All right, let's do another one. This one's a little trickier. You've got 12 and negative 3 as your coefficients, so you need numbers that multiply to negative 36 and add to negative 5. So 36 has a pretty decent amount of factors. 1 and 36, 2 and 18, 3 and 12, 4 and 9, 6 and 6. So which ones add to negative 5, knowing that I have to make one of them negative? How about, oh, these are 5 apart. There you go. 4 and negative 9. So I'm going to split the middle. 12x squared plus 4x minus 9x minus 3. Then I'll find the GCF of each half. The GCF of the first two terms is 4x, and 4 times 3x, 4x times 3x is 12x squared, plus 4x times 1 is 4x. Bring down the minus sign. GCF on the right side is 3. Negative 3 times positive 3x is negative 9x, and negative 3 times positive 1 is negative 3. At every stage of the game, you should be distributing backwards and just making sure 12x squared plus 4x, yes. Minus 9x, yes. Minus 3, okay, cool. If you do it right, you should have factors that are the same, 3x plus 1 and 4x minus 3. And I want to know when those equal 0. So if I wrote a little mini equation here, if I don't know when this equals 0, I would subtract 1 and then divide by 3. So x equals negative 1/3. Here I would add 3 and then divide by 4, so x equals 3/4. Those are your zeros for that problem. All right, let's try another one. Factor two terms, there's a minus sign. I feel like this should be dots, but these aren't perfect squares. GCF, they're both multiples of 3. 4x squared minus 9. Ah, now it's dots. So these are both perfect squares and they're being subtracted. So it's called a difference of two squares. The square root of 4x squared is 2x and the square root of 9 is 3. And when you're factoring dots, you're talking about conjugates. So one is plus, one is minus. I want to know when they equal 0. So here I would subtract 3 and divide by 2. If I set this equal to 0, I would add 3 and divide by 2. So negative 3/2 and positive 3/2 are my zeros. Number 5. All right, set it equal to 0 first. Make sure you move everything over to one side. 10x squared plus 28x minus 6 equals 0. Now, when you're factoring, it's a good idea to always look for GCF, and they're all even, so like it's gonna make the numbers smaller. Let's do that. Cut them all in half. 5x squared plus 14x minus 3. Now I'm going to factor this part. I'm ignoring the 2, but I'm going to factor that trinomial, which means I need numbers that multiply to 5 times negative 3 is negative 15, and add to the middle, which is 14. So 1 and 15, 3 and 5, 5 and 3 is a repeat. It's one of those two. What do I make negative to add to 14? There we go, negative 1. So the 2 doesn't change anything, so I'll just write it, but I'm going to forget about it. 5x squared minus x plus 15x minus 3. Then I'm doing the GCF of those two terms. That'd be x, 5x minus 1. Bring down the plus sign. The GCF between 15 and 3 is 3, 5x minus 1. And I think I did it right because those are the same, so 5x minus 1 is one of my factors. X plus 3 is the other, and don't forget the 2. There we go. I want to know when these equal 0. So I got a little mini equation here. I'd add 1 and divide by 5, so 1/5. And I would subtract 3, so negative 3. There's my factors, which those are my zeros, okay, or solutions to the equation in this problem. Cool, that's solved by factoring. Let's see what else we got. Oh, another analyze problem. Okay, so I'm going to go a little quicker here. I need numbers that multiply to 7 and add to negative 8. Well, 7's prime, so it's got to be 1 and 7, and they're both negative. X squared minus 7x minus 1x plus 7. So you split the middle. Negative 8 becomes negative 7 and negative 1. GCF is x, x minus 7 minus 1, x minus, that's not 7, 7. So my factors are x minus 1, x minus 7. Cool. What else you got? Convert to vertex form, so move the 7 over. Y minus 7 plus, I'll leave a blank. X squared minus 8x plus a blank. I'm going to complete the square on the right side, so half of negative 8 is negative 4, which means a 4 by 4 would be 16. I'm going to add 16 to both sides. Negative 7 and 6 make positive 9. On the right side, that's x minus 4 times x minus 4, so x minus 4 squared. X minus 4 squared, move the 9 over, minus 9. Now we have it in vertex form. So from vertex form, I can see the vertex is at 4, negative 9, and the axis of symmetry is x equals 4. The zeros, let's see, x minus 1 equals 0 at 1, and this equals 0 at 7, so 1, 0, and 7, 0, 1, 0, and 7, 0. And the y-intercept from standard form, y-intercept is 0, 7. So 0, 7 is the y-intercept. Let's draw all of that. 1, 2, 3, 4. There's my axis of symmetry. Let's see, what else? X-intercepts are 1 and 7. Yeah, okay. Y-intercept is also 0, 7. I can reflect that. Vertex is 4, negative 9. That's down here. So I got this lovely looking parabola. And when I draw it, it's beautiful. Okay. Cool. So there's my quadratic. What next? What are some ways you can check your zeros? So the equation that I have is x squared minus 8x plus 7. And we said that the zeros were at 1, 0, and 7, 0. So how can I check that? I can think of a couple ways. First of all, they're called zeros because when you plug them in, you get 0. So what if I do 1 squared minus 8 times 1 plus 7? 1 minus 8 plus 7 is negative 7 plus 7. Hey, that equals 0. Cool. I'll do the same thing with 7. 7 squared minus 8 times 7 plus 7. 49 minus 56 plus 7. You can use your calculator. That's negative 7 plus 7, which is also 0. Sweet. So I know that they are correct because when you plug them in, you get 0. But there's some other things I could do. I could solve it using vertex form. So if I had this equation and I set y equal to 0, I could say, okay, 9 equals x minus 4 squared, square root both sides, plus or minus 3 is x minus 4, and then solve. 4 plus or minus 3 equals x. 4 plus 3 is 7. 4 minus 3 is 1. Hey, I got the same answers a completely different way. That's a good sign. You could also do the quadratic formula. They would come out to be the same. You should also be able to look at your graph and tell me, hey, these guys are symmetrical about what I think the axis of symmetry is. So they're 1, 2, 3 away on both sides. That's a good sign. These are all things you should be looking for when you're checking your answers. But algebraically, probably the way that makes the most sense is to just plug them in and make sure you get 0. Mr. Wyatt is stuck. Yeah, that happens to the best of us. So why can't I factor this polynomial? Like something's going on. I would look for numbers that multiply to 2 and add to 6. So I make a table and like 1 and 2. Wait, 2's prime. 1 and 2 add up to 3. They don't add up to 6. So this isn't factorable. Okay, not every polynomial is factorable. So if this is not factorable, it's called prime. And I know that it's prime because, well, first of all, there's only one choice. But another way I could verify it is I could use the discriminant from the quadratic formula, which is 36 minus 8. That's 28. Well, 28's not a perfect square. And the only time a quadratic is factorable is when the discriminant is a perfect square. So why can't I factor this? The reason I can't factor this is because the discriminant is not a perfect square. Okay? If the discriminant were a perfect square, then it'd be factorable. But it's not, so I can't. I saved you my handwriting there. So what can I do to change it? Well, I do know that if these two numbers add up to 3 when you add them up. So what if I changed it to be x squared plus 3x plus 2? Then I could split the middle with 2x and 1x. And then I could factor it, x plus 2 plus 1. Hey, look at that, it works this time. So x plus 1, x plus 2. That'll do it. Or probably something else I could do is I could find two numbers that have factors that add up to 6. So what if I made it x squared plus 6x plus, what's some numbers that have factors that add up to 6? How about 5? 5 and 1. I could split the middle then. X squared plus 5x plus 1x plus 5, x plus 5 plus 1. Hey, look at that. It works this way too. Either one of these are correct. Doesn't really matter which one you do. There's probably other answers too, but those both work. If I could change one number, that would work. So that's everything that's going to be on your quiz or test or quest or whatever you want to call it tomorrow. You can rewatch the video, you can slow it down, you can pause, but if you can work through this, you can work through everything I'm going to throw you for quadratics. So good luck.